During the 18th century, the first scientific novel, A Voyage to the Moon, was created. Back then, we were dreaming of what scientific possibilities we can see outside of the world.
We were able to create, discover, improve on many scientific discoveries, instruments, and a lot more. And now, we are able to see the stars, galaxies, and now that we have the James Webb Telescope launched into space, who knows what in store for us.
Good day to you all. I am Shiva Cruz, telling you that with preparation, dedication, and passion, the impossible becomes possible.
And I am Angeline Kila, the president of the Bedan Society of Young Astronomers, saying, don't stop reaching for your stars. On behalf of the Bedan Society of Young Astronomers, we would like to thank each and every one of you for attending this webinar, especially for those um, from UP Astronomical Society.
We hope that all of us can spread the word and invite more people to join the club activities that we organize. At this juncture, may we call on Ms. Rene Bangog and Miguel Aliestante for the opening prayer and song, followed by the singing of the national anthem, Ms. Hannah Tan for the vision mission statement, a short message from our beloved moderator, Sir Jun Cajigal, and Ms. Angeline Kilang for her opening remarks, respectively.
Good afternoon, everyone. Let us pray all together in the name of the Father, of the Son, and of the Holy Spirit. Amen. Heavenly Father, as we begin this online webinar, we come to you asking for your guidance, wisdom, and support. Allow us to engage in productive conversation and become closer as a group. Strengthen our community relationships in order to help us widen our knowledge of the wonders of your universe. Guide our speakers and fill them with your grace as we make decisions that may have an impact on our daily lives. May you continue to remind us that all we do here today, everything that we achieve, is for the sake of pursuing truth, for the greater glory of you, and for the benefit of mankind. We beg all of this in your name. Amen. Saint Pete, pray for us. Saint Benedict, pray for us. Our Lady of Montserrat, pray for us, that in all things God may be God.
Here I am waiting, above in me I read.
All together, let us recite the vision mission statement of San Beda University. San Beda University, a Catholic educational institution, is committed to the Christian formation of the Bedan community as its service to the Church, the Philippine society, and the world. Vision. San Beda University envisions a community that is fully human, wholly Christian, truly Filipino, and globally competitive. Mission. San Beda University aims to form its members in faith, knowledge, virtue, and inculcate in them the Benedictine core values of prayer and work, ora et labora, that include study, community, and pursuit of peace.
Hello, greetings mga ka-spacers! I am Professor June Cajigal, the moderator and founder of the Bedan Society of Young Astronomers Manila. In behalf of the officers and crew of BSYA with Miss Angeline Kilang at the helm, and also in behalf of the administrators of San Beda University, Manila, we would like to greet everybody happy 29th National Astronomy Week 2022 with the team Maglayag Tayo sa Mga Tala. The National Astronomy Week or now is spearheaded by Pag-asa and is observed every third week of February under the Presidential Proclamation number 130 series of 1993. This year's celebration will be from Feb 20 to 26 with the theme Maglayag Tayo sa Mga Tala. In the ancient Baybayin script, the word for freedom, Malaya, could also be read as to set sail, maglayag, depending on the context in which it is used. Hence, this year's theme evokes the boundless freedom that awaits us all on our journey to the stars. Also, personally, I would like to thank those who are here ready to learn about the James Webb Telescope. The James Webb Telescope has been designed to answer many of the core questions that have animated astronomers over the past half century. With a $10 billion price tag, it is one of the most ambitious engineering initiatives ever attempted by man. So join us as we learn about the James Webb Space Telescope and its implications to humanity. So mga ka-spacers, have a great day ahead, live long and prosper, and always keep reaching for the stars. Maraming salamat po.
A pleasant day, young aspiring astronomers. I am Angeline Kilang, the president of the Bedan Society of Young Astronomers. Before I start, I would like to say thank you for every one of you who attended this webinar about James Webb Space Telescope and its implication to mankind. I would like to also thank my officers for helping me organize the event, and of course our moderator for moderating this event. I would also want to say thank you for our guest speakers who are very excited to talk about this webinar. And again, I'm Angeline Kila and hoping for your enjoyment in this webinar. Good luck and see you again later.
अस्सलामुअलैकुम। हम ज़मीन के रहने वालों की तरफ से आपको खुश आमदीद कहते हैं।
Hola y saludos a todos.
Greetings and friendly wishes to all who may encounter this Voyager and receive this message.
Hello.
ก็คิดว่าน่าเสียมาพวกเราในธรณีนี้ขอส่งมิตรจิตมาถึงท่านทุกคน
See anything a little more power
เจ้าทำก็ตะกับบ้านเลยเจ้าทำเขา
We step into the universe with humility and hope
ขอส่งมิตรจิตไปให้ยาตุลาอัสตะกอ
Hello from the children from the children of planet Earth. Hello, konnichiwa. Hello from the children of planet Earth. Hello from the children Hello, konnichiwa. Hello from the children of planet Earth.
I should like to extend.
Thank you very much, Miss Angeline Kilang.
And thank you very much to Miss Rain and Mr. Miguel Alestante, Miss Hannah Tan, and Sir Jun Cajigal for their wonderful speech. Before we proceed with this webinar, we would like to remind everyone to take notes and ask them during the open forum of this webinar.
In 1608, the first refracting telescope was made in the Netherlands, and the first person to put it to use was none other than Galileo Galilei. It's quite impressive how far we have gotten scientifically, astronomically, and of course, looking back, we were able to uncover many secrets, many questions, and now we are finding ways to discover more. Right, Angeline?
That is right, Shiva. Through centuries of research and development, we were able to learn more about this world, learn about ourselves, and of course, learn about space.
The highly awaited James Webb Telescope has been launched into space, and just like John M. Grunseld said, our journey in going beyond our home planet is a home endeavor, and in the greatest tradition of exploration, past, present, and future spacefarers will continue to be enduring catalysts for inspiration in our quest to unravel the mysteries of the universe. Our first speaker was the UP Astronomical Society Instrumentation Director, an undergraduate of the Bachelor of Science in Mechanical Engineering at UP Diliman, and is currently the National Astronomy Week Project Director. He's a very passionate and aspiring astronomer. I introduce to you Paul De Silva. May you give him a virtual round of applause.
Okay, everyone. Hello. Can you hear me? Naman. Okay. So, let me share my screen first. Okay. Okay, so can everyone see my screen? Yeah. I think okay naman. So for my presentation, I'll present actually included the history of telescope for this presentation so that you guys can have a better appreciation of the foundation that was laid by many scientists up until the launching of the James Webb Telescope. Okay, so let's start. So first of all, let's first define what is a telescope. So its purpose, it is an optical instrument designed to make distant objects appear near. So it ini-enhance nito yung our naked eye. Okay, so sa structure naman, it contains an arrangement of lenses or curved mirrors or combination of the two by which a ray of light is collected and focused and the resulting image magnified. Okay, so itong structure na to, makikita natin yan mamaya. Okay, so let's talk about first the power of a telescope. Okay, so there are three features of a telescope that enable them to extend the power of our vision. So the first one is the light gathering power. Okay, so basically it is the ability of the telescope to collect a lot more light than the human eye. So okay, so para magets natin siya. So yung analogy niya ay yung objectives and pupils ng tao. So the pupils of your eyes enlarge at night so that more light reaches the retina. So pag mas malaki yung aperture ng telescope, mas maraming light yung nag-gather niya. Okay? So that's the first power of a telescope. So the second one naman is the resolving power. Basically, is the ability of the telescope to make us see really small details and see sharp images. Okay, so for this power, and here sa left, you can see the poor versus good resolving power ng telescope. So yeah, objects that are so close together in the sky that they blur together into a single blob are easily seen as separate objects with a good telescope. Yan. So mas nadi-distinguish natin yung objects sa sky. Okay, so the last one is the magnifying power naman. So it is the ability of a telescope to enlarge images. So that's the best known feature ng telescope. Okay. So, but of course, since namamagnify niya yung object, namamagnify niya rin yung distortions yung noise basically. So magnification increases the size of image in the field of view, but a small fuzzy blob like this one becomes a large fuzzier blob and the contrast is less. So this one. Okay. So okay, let's make this webinar interactive. So can you guys answer this question? What is the least important power of a telescope? So what do you think is the least important power of the telescope among the three given powers? So you can chat your answers siguro.
Guys, if you know the answer, don't be afraid to raise your hand or type it in the chat box.
Kuya, if wala po, tawag ka na lang.
Okay. So,
yun, sir, meron po.
Yeah, okay.
Sa mga 11 STEM po, yung sagot po nila is magnification.
Actually, that's that's the right answer. Magnification is the least important power of a telescope. So if siguro tip na rin ito if gusto niyo bumili ng telescope. So for amateur and professional astronomers, they know that the light gathering power and resolving power are the most important. So it is critically dependent on the objective. Okay? So make sure na yung optics nung objective nyo, kung bibili kayo ng telescope ay excellent. Yeah, so okay, thank you sa mga sumagot. Okay, so let's go naman sa types, basic types of telescope. Yeah. So okay, so the first one naman is So the first one is the refracting telescope. So basically, it uses lenses to gather light and focus it to a point. So as we can see here dito sa image na to, ito yung telescope, then yung light papasok siya dito sa objective lens, dito sa lens. Then, pag pumasok yung light dito sa lens, mapo-form yung image dito. Na makikita naman natin din sa pagtingin din sa eyepiece. Okay? So some notes about refracting telescope. It is easy to use and consistent due to the simplicity of the design. So, yung design naman, like objective lens lang. So, basically yan lang yun. Then, yung yung objective, then eyepiece. Okay. So, it is good for distant terrestrial viewing. So, for lunar, planetary, and binary stargazing. Okay, so it is sealed. Sealed tube protects optics and reduces image degrading air currents. So, if yung air currents kasi parang nakaka-affect yan din sa quality ng image na makikita natin through the lens, through the telescope, okay? So, it need little or no maintenance since simple lang yung design niya. But yun, syempre, need pa rin natin siya i-maintain. Yan. So, it's hard to build on large scales. So, bakit siya mahirap i-build on large scales? Kasi, as we can see here, ito yung objective lens. Then, pag pumasok yung light dito, sa paglaki nitong objective lens, mas haba itong lines na to para makita natin yung image. So, kaya siya mahirap siya i-build on large scales. So, these are some variations naman of refracting telescope. Okay. So, the second one, it's the reflecting telescope naman. Basically, it uses mirrors. It uses mirrors to focus light from distant objects. So, yan, another image here. So, yung light, papasok siya dito. Then, meron tayong mirror dito sa loob na magre-reflect yung light dito na makikita naman natin dito sa eyepiece. So, basically, yan yung design ng mirror or reflecting telescope. So, some notes ulit. It's easy to use and construct. Okay? It's actually excellent for faint, deep sky objects. So, like remote galaxies, nebulae, and star clusters. Okay? So, it is slow in optical irregularities and deliver very bright images. It is reasonably compact and portable. So, isa pang advantage ay it can be produced at less cost than lenses. But yung disadvantage naman niya, slight light loss due to secondary obstruction when compared with refractors. Yan. So, it may require a little more care, maintenance, and alignment. So, yung alignment kasi, may tendency yung reflecting telescope natin na ma-misalign. So, kailangan natin siyang i-maintain or i-align if mangyari yan. So ito yung some variations naman ng reflecting telescope. Then for the last one naman, basically parang pinagsama lang natin yung concept ng reflecting and refracting. So it uses both mirrors and lenses. So ito naman yung graph. Ito yung representation niya. Okay? So for the catadioptric, it is the most versatile type, generally speaking. So it has the best near focus capability of any telescope, first rate for deep sky observing or astrophotography if mahilig kayo sa mag-take ng pictures of the sky. It is also excellent for lunar, planetary, and binary star observing, plus, of course, terrestrial viewing. It is closed tube design, reduces image degrading air currents. It is also compact and durable. So, like refracting telescope, may slight light loss then due to the secondary obstruction. So, these are some variations naman of catadioptric telescope. Okay. So another question again, if nakita niyo na yung itsura ng James Webb, no? What do you think naman? See, na flash ko na yung sagot. Pero basically, James Webb is a Cassegrain reflector. So pag makita niyo later yung design niya, meron siyang large primary mirrors na nagko-collect ng light, tapos na nafo-focus dun sa secondary mirror, right? So yun yung James Webb Telescope. So next, para naman ma-appreciate natin mamaya yung discuss ko about history of telescope. So let's talk about aberrations or the defects in images produced by a telescope or optical system. Okay. So the first one, ito yung pinaka madali na makikita if na-try nyo nang gumamit ng telescope. So chromatic aberration. So it is the failure of lens or lens system to bring all colors to a common focus. So in here makikita natin yung image na parang, di ba? Para siyang meron siyang rainbow-like na aberration here. So basically that's the chromatic aberration. Okay. So yan, note na lang din na it is caused by the unequal refraction of light across the spectrum. So yung spectrum, yun yung that's basically the lens. Tapos pag pumasok yung light, if hindi maganda yung pagkakagawa dun sa lens, so magkakaroon ng unequal refraction. So magkakaroon ng chromatic aberration. Okay? So second one is the spherical aberration.
Yung bako charger din sa laptop.
Okay. So the spherical aberration naman, it is the failure of rays passing at different distances from the center of a lens or mirror to come to the same focus. So basically, mas madali siyang intindihin pag tinignan natin yung images dito. So para siyang nagkakaroon ng outer glow, no? So spherical aberration. So next naman is the coma. So it is type of spherical aberration from rays that come in off-axis. So off-axis siya. So yan, same lang din yung image na ginamit natin kanina. Pero yung aberration naman niya is like parang naging comet siya. Okay. So the next, siguro familiar naman din kayo dito, astigmatism, lalo na din syempre na-experience natin to din sa mata. So it is another off-axis effect that causes rays from star or source of light to come to different focal points in the vertical and horizontal plane. So this is the normal image. Tas ito naman yung image na pag merong astigmatism. So the fifth one naman is the curvature of field. It is the failure to focus the entire image on a single plane perpendicular to the optical axis. So yan. Parang may hindi siya nagfo-focus ng ayos. So for this one, nag-focus siya dito sa gitna pero blurred siya dito sa gilid. Then dito naman nag-focus siya dito sa edge pero blurred din sa gitna. So okay, so the last one naman na discuss natin for aberration is the distortion. Okay, so variable magnification across the field of view. So meron tayong two types ng distortion. Merong distortion, barrel distortion and pincushion. So yung barrel distortion, para siya nag-bloat. Para siyang puputok in a sense or pupunta sa atin. Then yung pincushion naman, para siya napupush. Basically, yun yung pinagkaiba ng barrel and pincushion distortion. Okay? Okay, so another question again. What is the most serious aberration that affects refracting telescope? Yan. So if alam niyo guys yung sagot, just kahit hindi, just try to guess the answer. So among that 6 aberrations, ano sa tingin niyo yung the most serious aberration na nag-a-affect sa refracting telescope? Okay? So, ano sa tingin nyo guys? Yung most serious?
Sir, meron po sa comments sa chat box, sir, nag-answer ng chromatic.
Okay? That's right, actually. Chromatic. So, kagaya nga nung sinabi ko kanina, ito yung chromatic aberration. So, I'll explain this through sa refracting telescope. Since gumagamit nga siya ng lens, so ito yung spectrum natin. Then, papasok yung light dyan. Tapos, nagkakaroon siya ng chromatic aberration kasi yung light nagdi-disperse siya. So, hindi siya pumupunta sa isang common focus. So, makikita niyo dito, nandito yung blue, nandito yung green, nandito yung red. So, hindi sila nagka-come into one common focus. So, kaya nagkakaroon ng chromatic aberration mostly sa refracting telescope. Okay? So, yeah. That's all dun sa basics ng telescope. So, let's go naman sa tools of cosmology. Yan. So, the telescope, one of the central instruments of the scientific revolution, soon became the astronomer's most essential tool. Okay. So, early makers of eyeglasses and lenses. So in the 1400s until 1500s, glasses were used widely across Europe. However, these lenses were not powerful, not polished, and not clear. So, diyan nagsimula yung dito na siguro masasabi natin na nagsimula yung pag-invent sa telescope. Okay. So, yan. So some notable figure, si Hans Lippershey. So in 1608, isa siyang Dutch eyeglass maker. Kinlaim niya na siya yung nag-invent ng first refracting telescope. So yung refracting telescope niya, concave eyepiece aligned with a convex objective lens. So at the time, since scientific revolution, once na may ma-invent ka, mag-apply ka for a patent. So, nag-apply siya for a patent, but he was denied due to the claims of other spectacle maker that they had made similar devices. So, yung at that time kasi, sobrang simple lang yung design ng telescope na madali lang talaga siyang gawin. So, maraming nag-claim ng patent, kaya hindi na-grant. Pero si Hans Lippershey yung first na nag-apply for patent ng telescope. Okay, so yan yung itsura ng refracting telescope ni Lippershey. Okay. So, pero at that time, hindi pa ginagamit yung telescope for astronomy. So, after pa niyan, na ginamit yung telescope for astronomy. Yeah. So, yung first, siguro alam na to ng iba, yung first na gumamit ng telescope for astronomy ay si Galileo Galilei. Okay, so he heard about Lippershey's device in 1609, and he immediately set about building his own version of telescope. So same lang sila, refracting, since lens yung ginagamit at that time. And siguro fascinating din na malaman na narinig niya lang yung device device ni Lippershey, pero nakagawa na siya ng own version niya. So he is the first recorded person to point his telescope skyward or to use it for astronomy. So yung kay Lippershey, yung magnification ay 3 times, pero yung kay Galileo Galilei ay 8 times, but was soon refined to 20 times magnification. Okay. So, yan. Some images din sa ito, Galileo Refracting Telescope. So, ito yung itsura ng refracting telescope ni Galilei. Then, nung first na ginamit niya yun for astronomy, kasi at that time, naniniwala yung mga tao na celestial bodies na nakikita ng naked eye ay flawless. So parang nakita nila yung moon as sphere lang. Pero nung tumingin si Galileo Galilei dun sa telescope, nakita niya na imperfect yung moon, na merong craters, merong cracks. So isang malaking discovery yun for mankind. And then na-discover niya rin yung basically through the phases of Venus, na-discover niya or na-debunk niya yung geocentric view, na which means na yung Earth daw yung nasa gitna ng system. So pero sadly ang nangyari kasi dito, at that time parang ang claim ng Roman Catholic ay geocentric view. Yan. So hindi sila naniniwala dun sa claim ni Galileo, para kasing yung statement niya na heliocentric yung model ng solar system, parang it was a challenge din sa Roman Catholic belief at that time, kasi naniniwala nga sila na geocentric yung view. So na prosecute si Galileo Galilei, then na-house arrest siya hanggang sa namatay siya. Pero di ba, alam naman natin, generally accepted ngayon na heliocentric yung accepted. Okay. So next naman ay si Johannes Kepler or Johann Kepler. So he made detailed studies of telescopic optics and devised his own apparatus with two convex lenses. Okay, so ito yung Keplerian telescope. So, however, it was accompanied by more spherical and chromatic aberration. Okay, so paano nagkaiba yung Kepler and Galilean telescope? So itong kay Galileo, gumagamit siya dito ng convex na lens, tapos ito naman ay concave. Then kay Kepler naman, gumagamit siya ng dalawang convex. So ito yung image. So parang ganito nila tinitingnan, pero yung image, nakikita niya na kung ano yung orientation niya. Pero sa Keplerian naman, nakita niya upside down yung image. So after that, Sir Isaac Newton naman, he believed, amongst other things, that mirrors would solve the chromatic aberration issues that plague refracting telescopes. So in-invent niya yung Newtonian telescope. So it is the first reflector. So si Sir Isaac Newton yung first na nag-incorporate ng mirror sa telescope. Okay? So ito yung itsura ng Newtonian reflecting telescope. So kung mapapansin nyo, dun sa previous na telescope, mas maiksi siya. Mas maiksi yung telescope ng reflecting compared sa refracting. And mas malakas yung magnification niya compared dun sa refracting. Okay, so next naman is si Sir William Herschel. So in 1789, the first giant reflector telescope was built in the United Kingdom. So he mapped out the star distribution of Milky Way galaxy and discovered Uranus as a planet. So ito din, isang malaking discovery din tong nagawa ni Sir William Herschel, kasi sa time ni Sir Isaac Newton, yung farthest planet from the solar system ay Saturn. So naniniwala sila na yung Uranus at the time ay hindi isang planet kundi isang star. Pero na-debunk ni Sir William Herschel. So yeah. So ito yung reflector telescope na binild ni Sir Herschel. So ganyan siya kalaki, 40 feet or 12 meters. Then next naman ay si Sir William Parsons. So ano na to, no? 1800. So he's an Irish astronomer and builder of the largest refracting telescope, the Leviathan of the 19th century. So, ginawa niya to at the time, 1844 to 1846. So, ginamit niya tong largest refracting telescope at the time to study nebulae or the fuzzy clouds, and became the first person to observe the spiral trams of the M51 nebula. So, it is si William Parsons more on the study of nebulae yung ginawa niya through the use of telescope. Okay? So, ganyan kalaki yung telescope na binild ni Sir William Parsons. Okay? So, next naman, Sir George Ellerslie Hale. So, he founded the Yerkes Observatory, sometimes referred as the birthplace of astrophysics, that would become the world's largest refracting telescope at the time in 1897. So, yung maganda namang breakthrough dito, parang na-push yung limit of the maximum size ng refracting telescope. So, it used the biggest lenses possible without having the entire apparatus collapse under its own weight. Okay, so, pero, kahit anong push na limits ng mga astronomers, scientists, parang hindi pa rin sila contented doon. Kasi yung aberrations na nangyayari, na nakikita sa telescope ay hindi na internally, kundi dahil sa atmosphere ng Earth. So, lumabas yung idea na what if maglagay tayo ng telescope sa outer space. So, yan. Telescopes here on the ground, which also must peer through Earth's atmosphere, are equally vulnerable to our atmosphere's visual tricks. So, diba yung reason kung ba't nagtitwinkle yung stars ay dahil sa Earth's atmosphere. So, para daw mawala yun, para mawala yung problem na yun, what if maglagay na lang tayo ng telescope sa outer space. Okay? So, yung most famous na alam nating lahat is the Hubble Space Telescope. So, it was first conceived in the 1940s and initially called the Large Space Telescope. So, pero 1940s nabuo yung idea ng Large Space Telescope, pero nagsimula lang yung paggawa sa kanya 1970s by the NASA with contributions from the European Space Agency. Okay? So it was named after American astronomer Edwin P. Hubble. So si Sir Edwin P. Hubble naman made contributions naman sa theory about Big Bang na nag-expand yung universe. Okay? So some dates sa Hubble Space Telescope. Nilaunch siya noong April 24, 1990. So roughly 20 years, 2 decades. Then yung decay date naman niya, kung kailan siya hindi na siya magagamit, ay estimated around 2030 to 2040. Okay? So yung wavelengths na nade-detect niya or yung wavelengths na ginagamit niya para tumingin, para makita yung mga images is near infrared to ultraviolet. Yan. So some facts about Hubble. It has made more than 1.3 million observations since its mission began in 1990. And sa cost naman, approximately $16 billion. Diba? Sobrang laki. Pero it is adjusted for inflation. So nung in-adjust yung inflation, kasi syempre hindi yung currency at that time ay hindi naman pantay sa currency natin. So nung in-adjust nila yun, it is approximately $16 billion yung Hubble telescope. Okay. Okay, so hindi ko pala nasabi, pero yung Hubble Space Telescope ay serviceable siya. Ibig sabihin, may astronauts na dinedeploy sa kanya para i-upgrade siya, ayusin, or basically i-upgrade at ayusin. So sa tingin nyo, ilang beses, how many times was Hubble serviced or repaired or upgraded? Okay. So check lang natin kung may wild guess kayo about that. Kasi di ba, sobrang tagal na niya. 1990s tapos 2022 na ngayon. So roughly 33 years, 32 years. So how many times do you think? Okay, sabi ni Sir Louis ay 3 times. Okay, others 5 times. Okay. That's the right answer actually. 5 times. Okay. Since parang yung ang idea kasi dito, pwede naman siya na gawing mas madami, pero yung cost nga niya, yung cost ng pagsa-service, pag-deploy ng service mission sa Hubble space ay mahal. So yung ano lang, so tinan niyo yung timeline niya. 1993, 1997, 1999, 2002 then 2009. So itong first mission naman is mostly sa pag-repair ng Hubble space kasi nung dineploy yung Hubble space tapos nandun na siya sa orbit ng Earth, nag-orbit na siya dun sa Earth, may slight lang, may konting misalignment dun sa mirrors. So nag-deploy sila ng 5 astronauts for that para maayos. Okay. Then itong iba naman ay mostly for pag-upgrade ng telescope. Like pinalitan nila yung mga main components. So I think dati kasi at the time parang visible light lang yung nakikita niya and visible and ultraviolet. Pero yun nga, in-upgrade nila yung Hubble space para makita ng Hubble space yung at least near infrared. Okay? So, yan. So, nandito naman tayo ngayon finally sa James Webb Telescope, which is the largest and the most powerful space telescope ever launched. Okay, so yan, the NASA-led development of the telescope in collaboration with the ESA or European Space Agency and Canadian Space Agency. So it is named after James E. Webb, who was the administrator of NASA from 1961 to 1968. So mas kilala si Sir James Webb dun sa Apollo programs. Okay. So dates then. So launch date niya ay last year, December 25, 2021. So kung alam niyo ng iba, saktong Christmas Day siya. And yung decay date naman niya is 10 years yung plan, pero yung expected talaga is 20 years. Pero for the James Webb Space Telescope first primary mission, it will take 5.5 years. So ganun katagal. So approximately 20 years hindi na din magagamit yung James Webb. So take note na lang din na itong James Webb Telescope ay hindi siya serviceable like Hubble. So hindi pwede magpadala ng astronaut diyan kasi yung placement niya ay mas malayo dun sa kung saan naka-place yung Hubble para better view. Okay, so nag-improve yung wavelength niya na nade-detect. So solely infrared na lang siya. Okay, so malalaman natin kung bakit ba mahalaga tong infrared, kung bakit ba mahalaga yan. So sabi nung developers, nung astronomer scientists, it is designed to see light from the earliest galaxies to form after the Big Bang, and will let scientists study the atmospheres of planets that orbit distant stars to search for signs of life. Okay, so yung basically yung sinasabi dito, parang yung pinaka main purpose ng James Webb ay makita natin yung kung paano nabuo, or basically about Big Bang. Paano nabuo yung stars, yung planets, galaxies. So yan. Kasi yung light, for example, yung light na nakikita natin, let's say tumingin tayo sa isang star, yung light na nakikita natin doon ay hindi yun yung appearance niya at the moment. Kasi nga, 'di ba, yung sobrang layo nung nung distance, light years. So yung nakikita ni James Webb ay mas malakas dun sa kay Hubble, which is I think yung kay Hubble ay 13.7 billion light years yung kaya niyang makita. Okay? So yung cost naman niya approximately $10 billion. So malaki din. Okay? Yan. So paano na-upgrade? So isa lang to dun sa mga upgrade na meron from Hubble to James Webb Space. Okay? So dito sa left, ito yung visible light. Like ito yung nakikita lang nung eyes natin. Okay? So yan yung na-detect nung Hubble Space 2001. Okay? So after yun yung servicing mission, nagkaroon na siya ng near infrared or infrared na wavelength. So ito na. As you can see, mas maraming stars tayong nakikita sa infrared compared sa visible. So isa lang yan din sa mga scientific breakthroughs na meron din sa from Hubble to James Webb. Okay? Okay, so balik tayo dun sa main topic natin, no? James Webb Telescope and its implication to mankind amidst the COVID-19 pandemic. So yung interpretation ko dito, kasi I see this statement na parang yun nga, ano yung implication ng James Webb sa mankind amidst, like, hindi lang sa COVID-19 pandemic, kundi sa iba't ibang issues concerning revolving around humanity, no? So parang as nakita ko nga yung cost nung iba't ibang space exploration, so parang ano siya, thought provoking. Parang mapapatanong ka na lang kung should we spend more money on space exploration ba? Should more money be spent on space exploration rather than to solve humanitarian problems? Then, okay, so I listed down some of the things or implications ng James Webb, or basically yung space technology, space exploration. So time passed by, pero yung the thirst, sabihin natin thirst for celestial knowledge remains the same. So nandiyan yung nature talaga ng humans na i-exceed yung limits nila. Like in nature, curious na tayo. So hindi nagbabago yan as time passed by. Nandun pa din yun. Then it will help us map the universe and physical living conditions. So from previous space explorations, kahit hindi pa yung James Webb mismo, from satellites, di ba? Ginagamit natin yung satellites para makita yung physical living conditions sa Earth. Like makita kung anong place yung basically yung forecast ng weather, kung paano naapektuhan yung world ng climate change. So yan. So it is also a massive investment for humanity. Okay, so siguro share ko na din na may nabasa akong isang article na yung space technology na ginamit dun sa Hubble space, I think spectrograph ata yung tawag dun, ay ginamit din para to aid breast cancer. So ginamit yung space technology as to solve problems on Earth. So yeah, space technologies can be adopted to solve problems on Earth. Or yeah. Okay, so yeah, so basically telescopes have revolutionized our understanding of ourselves and our place in cosmos. Okay? So kung nasaan tayo sa universe, and let us just remember na with a new telescope like the James Webb Telescope, we're always gonna find something new because new telescope always add to our ability to see more. Okay, So again, I'm Paul De Silva from UP AstroSoc and Ad Astra per Aspera. Thank you.
Thank you very much for that wonderful and informative lecture, Sir Paul. Shiva, what are your takeaways from this lecture?
Well, to be honest, there are a lot of things that I was able to learn from the lecture of Sir Paul. Specifically, it cleared some misconceptions, more on the past, on the creation, on our journey to creating the, or rather, the history of astronomy as a whole. So basically, Sir Paul also gave me an insight when it came to the different types of telescopes and there are so many more that I can go into, but I'd rather talk about them during the open forum, which I guess our viewers who are watching in social media right now or through Facebook, and the viewers that we have in the meeting right now currently. If you do have any questions, ask them later once the open forum starts. So before we proceed with our next speaker, like I said, for those that have questions to Sir Paul De Silva, the question and answer forum will be open after the next speaker finishes his talk. Now, let us proceed with our next speaker.
Our second speaker was a former member of Astronomical League of the Philippines and now a co-founder of the Manila Street Astronomers, who is very engaged with astronomy and very excited to talk about James Webb Telescope. Proudly presenting to you our passionate astronomer, Mr. Christopher Vu. Sir Lou?
Hello, good afternoon, everybody. Hello, can you hear me?
Yes po, sir.
Okay.
Sir, medyo nag-echo. Ayan.
Okay na?
Pakimute na lang po siguro, sir, ng other device po.
There you go. How's that?
It's better, sir.
All right. Thank you so much. Good afternoon, everybody. I'm so excited to be here with you all. I would like to thank, before anything else, happy National Astronomy Month, Astronomy Week to everybody. I would like to thank Sir June Cajigal and the officers and staff of the SYA, and of course for the students and the teachers and the faculty of San Beda for inviting me to be part of this and to talk about the James Webb Space Telescope. And by the way, in my excitement, in making this, in doing this talk, I actually bought myself a shirt. And this, wala lang, addict lang. I'm just, wala lang. I'm just so excited about this scope. Anyway, if you've been following the astronomy news for the past couple of months, you've probably heard of the James Webb Telescope that has been recently launched in last December, and as mentioned before, the James Webb Telescope is the most advanced, the most innovative the most expensive space telescope to date, right? So you may ask yourself the question, why another space telescope? I mean, don't we have enough telescopes in the world to do observations? And why another space telescope, and why so expensive? So, but believe me when I tell you that the hype for this telescope is real. All right, every astronomer, every astrophysicist that has and amateur astronomers as well are all excited about the James Webb Space Telescope. So let me just walk you through let me just walk you through as to why James Webb is such an important scientific device. Okay, so let me just share my screen here for a minute. And here we are. Okay, yeah, it's the James Webb Space Telescope. As you can see, the design of this telescope is not your conventional looking telescope, no? Like yung pinakita ni Sir Paul earlier, where you see yung telescope is usually encased in a tube, while this telescope has a very innovative design, and there's a reason for that, no? And we hope we get to talk about that a bit later on. So I broke down the presentation into four parts. We're going to briefly discuss the timeline ng James Webb Space Telescope, a brief look into the long and torturous journey from proposal, design, build to launch ng telescope na to. And then letter B, we talk about the launch itself and yung deployment, which means how this telescope unfolded and transforms, like an origami, no? And actually put the transformers. I'm talking about the toys and the movie. It puts all transformers to shame. Okay, and in part C, we'll be talking about the science instruments that are part of that is part of the telescope itself. And then finally, on letter D, the part D, we are talking about looking forward to the past. See what I did there? Play on words, right? If you're an astronomer and you have an understanding of how light behaves as it travels through long distances in space, you'll be busting a gut right now. I'm telling you. Anyway, moving on. Let's talk about the brief timeline of James Webb Space Telescope. So, yeah, on September 13 of 1989. By the way, ganito, let's just do a little maliit lang na game. As you know that the James Webb Space Telescope has a 32 years from proposal, build to launch. 32 years ang lumipas. So I'm pretty sure that most of you has your year of birth posted on this presentation, on this slide. So if you see your birth year, just raise your hand. Do it on the chat. Just a little game lang natin. Okay, so let's start. September 13, 1989. This a group of astronomers met in Baltimore, Maryland, in the Space Telescope Science Institute. Okay, and they talked about the next generation of space telescopes. Next generation. So I want you to take note of this. 1989, sila nag-usap of the next generation telescope na magiging successor ni Hubble. Hubble is launched in April ng 1990. So a year before Hubble was launched, astronomers are already conceptualizing the next generation na telescope. What type of telescope would it be? Ano yung i-observe niya, and all that. So then in 1996, somewhere in 1996, the next generation space telescope was initiated, meaning nagkaroon na siya ng pondo. And initial na fund na binigay kay James Webb Space Telescope is actually $8 billion. Yun yung initial. In cooperation, of course, with the European Space Agency and the Canadian Space Agency. The Hubble Space Telescope was a collaboration between NASA, European Space Agency, and European Space Agency. Dalawa lang sila eh. But this time, because of this huge endeavor, because of the scope of what James Webb will do, tatlong space agencies na ang nag-collaborate, which is NASA, National Aeronautic and Space Administration, the European Space Agency, and the Canadian Space Agency. Okay, so initial funding is $8 billion. Wow. Okay, so next, in September of 2002, the next generation, the NGST, Next Generation Space Telescope, was renamed to James Webb Space Telescope. Of course, nabanggit na ni Sir Paul that James Webb Space Telescope was named after the director of the Mercury, Gemini, and Apollo missions, James Webb. Yeah. So, and then on September 11 of 2003, the James Webb Space Telescope was awarded to Thomson Ramo Woodridge Incorporated. Okay, now marami din kasi nagpasa ng design of the next telescope to be built, and here are some of those designs na ni-propose. Take a look at these two. See, this is a design by NASA Goddard, and the one is Ball Aerospace. Ito, Lockheed Martin. And ito yung design, finally the design that they thought. Of course, yung nagkaroon ng modifications sa design ng TRW, that's the Thomson Ramo Woodridge Incorporated. Yung design nila eh. Yung initial design nila. They nagkaroon ng konting tweaking, nagkaroon ng konting and the design became what it is we see today. Of course, of course, there are other designs bukod dito. Actually, merong nga nag-propose ng next generation na telescope was to be built on the surface of the moon. Gagawa daw lang somewhere in the sa south pole in one of the craters on the south pole of the moon. Merong isang crater doon that where sunlight never encounters that part of the moon. So they plan to build a space telescope dun sa southern part ng moon on the lunar surface. But logistically it's difficult, next to impossible to keep and maintain a lunar based na telescope. So continue tayo dun sa timeline natin ulit. So on July of 2011, the James Webb Space Telescope was threatened to be cancelled. Now take a look of yung gap na nangyari between 2003, ilang years siya, no? 2003 to 2011. Ang tagal, ang daming redesigning, mga design flaws na kailangang i-reassess. Merong mga certain materials, materials na kailangan i-redesign because syempre once again, this is a non-serviceable na space telescope. So it has to be perfect. Once it's built, it has to work perfectly. Ibig sabihin. Kaya hence, ang tagal nilang ni-design ang mga components nito, all of the heat shielding and yung mga the computer software, the writing of the all that fits into that 2003 to 2011 na years na kinain ng research and development. So there was a point where certain astronomers or certain investors in this project started asking the question, is it worth it? Is this worth it? But in November of the same year, November of 2011, the James Webb Space Telescope has survived that cancellation. Somehow the investor says, yeah, we should be doing this. We must do this. So nag-push on yung project, and then on sometime between in 2012, the MIRI is the mid-infrared imager, was completed and handed off to NASA for installation sa telescope itself. And then on March of 2013, FGS is the fine guidance system ng fine guidance system ni James Webb, at in-install na siya sa ISIM. ISIM is the Integrated Science Instrument Module. And then on July 2013, the MIRI, yung pinag-usapan natin kanina, the MIRI is installed on the ISIM. And then on March of 2014, NIRCam and NIRSpec is installed in the ISIM. Now, NIRCam pala is the near infrared camera, and the NIRSpec is the near infrared spectrograph na installed sa ISIM. Okay, and then on February of 2015, the 18 hexagonal segments ng primary mirror is completed. There are 18 na individual na mirrors na gawa sa it's not just made of glass. It's also mounted on beryllium struts, and then it was mounted on beryllium struts, and then yung mirror na yon is coated with gold. Kaya kita mo kulay, that yellow thing yung big yellow thing na nakita ninyo dun sa telescope, that's actually gold. Okay, manipis lang na gold. Why gold? Because once again, this telescope is actually fine-tuned to see infrared light, and gold is a good reflector ng infrared. So gini-coat lang nila yun ng a very very thin coating ng gold. And then then in December of 2015, a launch date was set. The launch date was set on October of 2018, which is, I'm kind of excited about that. Nung time na yun, personally, I was excited kasi the first time I heard about this James Webb Space Telescope was nung 2012 ko na nalaman about James Webb Telescope. And back then, excited na ako to learn what of the things that it can do. And then nung sinabi nila na ilo-launch sa October of 2018, I got excited kasi October is actually my birth month. So it parang for me, parang inisip ko, ang galing parang this would be like a birthday gift ni NASA sa akin. Di-launch dito si James Webb Space Telescope on October. So and then on March of 2016, the secondary mirror was installed. Yung nakita yung naka-strut na ito yung salamin ng James Webb. Yung secondary mirror is the one in the tip, yung naka-strut na ganon. Kasi yung dito sa dulo, ito yung secondary mirror. Yun. So the secondary mirror was installed, and then on November of 2016, the James Webb Space Telescope construction is completed. Buong-buo na siya. Yeah. Now, after nila nabuo yung James Webb Telescope nung time na yun, off to testing. Marami silang iti-test. Vibration test, noise test, all that. Tsaka deployment test, all of that, inan nila. They test nila yon just to make sure that nothing goes wrong. No bolts, walang mga bolts na matatanggal, which by the way happened during testing. Kaya one of the things kung bakit na-delay din si James Webb. So moving on, we're at 2016 na, no? Oh, yung mga birth year niyo, don't forget. Raise your hand kung na-mention yung birth date niyo. Then on March 27, 2018, the launch, di ba, yung launch date natin is October of 2018. On March 27, 2018, so 7 months before the launch, na-delay. It was delayed till May of 2020. Ito yung nangyari na in the vibration test, yung isang bolt na nakakabit sa loob ng sun shield, isang bolt nalaglag. And then they had to look for the bolt. They have to disassemble some parts para mahanap din yung bolt because that would cause problems pag na-deploy na siya. So they had to redo everything. And then on June 27, 2018, once again, na-delay yung sa May to 2020, once again, na-postpone na naman siya to March of 2021. Okay, na-postpone siya. Bakit? Ito yung masakit. During the time na tinetest nila yung deployment ng sun shield, one of the sun shield accidentally ripped, napunit. And it caused, syempre, napunit yun, you have to replace that, you have to reorder the materials para mapalitan yung napunit na sun shield, and then you have to install it, disassemble, and reinstall it. So, na-delay siya. And plus, what happened is, nagkaroon ng an independent review board, once again reassessed kung if it's still worth, if James Webb Space Telescope is still worth launching, is it still worth sending off to space? Pero when so ang ginawa ng independent review board, they reassessed the cost versus the cost, versus the potential discovery and exploration na gagawin ni James Webb Space Telescope, and they assessed na that the exploration and the discovery is well worth the cost. So instead of saying cancel na, ni postpone lang nila yung launch. Then on July 16, 2020, the launch once again was postponed. Once again, on October 31 sa 2021. Once again, I was hopeful again na magiging birthday gift to ulit ng NASA para sa akin. But that's just me. Dahil sa COVID-19, dahil at this time, kalagitnaan na tayo ng COVID-19 pandemic. And syempre, a lot of precautions has to be made para to keep engineers, scientists, and designers safe from this pandemic. And then on June 1, 2021, the launch again was postponed on November 2021. And then once again, sunod-sunod na yung postponement, delay, postponement, delay. Basically because marami kasing testing na ginagawa, maraming refits and redesigns na ginagawa. And of course, meron din time na nagkaroon ng problema ang software, whereby the James Webb Space Telescope is not communicating well with the Ariane rocket, the rocket where James Webb is supposed to be launched in. Merong software na hindi sila nagko-communicate ng maayos, so it has to be rewritten and all that. So yan, delay until finally they decide na when everything is okay na, it finally launched on December 25, 2021. That was 12:20 Universal Time, or dito sa Philippines, that's around 7 or 8 Philippine Standard Time. Finally, kung binilang nyo kung ilang taon yon, that's 32 years. 32 years, right? Now, to give you an idea kung gaano katagal ang 32 years, yung New Horizons, anybody here heard about the New Horizons probe? That yung probe na pumunta sa planetang Pluto, remember that? The New Horizons probe was launched on January of 2006, and it took 9 years for that probe to reach Pluto. Dumating siya kay Pluto July of 2015. Nangyari na yung launch, and nakarating na siya si New Horizons sa Pluto. Si James Webb andito pa rin, hindi pa rin nalo-launch. Ganun katagal yung duration ng design, build and launch ni James Webb. And the main reason kung bakit ganun katagal is because they want James Webb Space Telescope, once launched, has to work perfectly. Kasi once again, hindi siya serviceable. Hindi katulad yan ni Hubble na pwedeng puntahan, aayusin lang natin, tighten a few screws, palitan ng mga components, and we're fine. Ito hindi. Because it has to travel 1.5 million kilometers away from the Earth. Okay, and we'll be discussing we'll be discussing that part of the deployment of James Webb mamaya. Okay, so ganun katagal. So then yun din ang reason kung bakit ganun katagal ang pag-launch ni James Webb Space Telescope. So these are a couple of screenshots that it took. Actually, but December 25 to ni-launch. I was nasa ano ako noon eh. At the time I was celebrating, I was with family kasi syempre Christmas. Pero everybody else was watching Netflix, sa Christmas movie sa Netflix dun sa living room. I was in the corner of the kitchen and I was watching this live nung live launch nito nung December 25. And I was smiling at myself, and I was really excited ako to see this thing launch. Finally nag-launch siya. And it was the launch was from the launch site from Kourou, French Guyana. French Guyana. Yun yung launch site nito, no? It's malapit sa Brazil. And here's something that you kids could do a little research on. And it's in a form of a question. And ganito yung question ko. Why is it beneficial for launch sites to be closer to the equator? Yun yung question ko sa inyo. Kayo, sige, find the answer. Why is it beneficial for your launch site closer to the equator? Yeah. Okay? So once again, balik tayo. So na-launch na siya. This is the Ariane 5 rocket. Ni-launch siya. And ganito yung itsura actually ng what's inside the Ariane 5 rocket, no? So all this part right here, all this is fuel. Ito yung launch vehicle, and all this is fuel. And si James Webb is on the top. As you can see, si James Webb right here is folded up in such a way to fit sa ganitong configurement, yan, sa ganyang containment, no. They had to design this telescope, which is the size of a tennis court, by the way, to fit sa nose cone, sa payload bay ng Ariane 5 rocket na to. And of course, once it's launched, and then there's mga stages where rocket stages where natanggal yung rocket from the side, and then nag-launch din yung nose part ng yung payload ng Ariane 5. And inside that, once na release si James Webb, yung transformation niya began. Okay? Now, I want you to look at this. Yeah. So yung first day ng launch niya, when it was launched on the first day, the first thing na dineploy niya is the sun array, yung solar array niya pala, yung solar array. This is responsible for internal power. Siyempre, he'll get solar power and convert it into electricity, and then that gives James Webb its internal power. The next thing na dineploy ni James Webb is yung the second thing na deploy niya is ito. Ito, no. This is the yung antenna niya para maka-communicate si James Webb with Earth. Okay. And then on day 3, it deployed its solar shields, yung shield pallets niya. First yung sa likuran niya. First yung likuran, deploy yung back pallet, and then the front pallet yung sumunod. Now, ni-deploy din tong flap na to, tong maliit na flap sa likod. What this does is actually it's a parang stabilizer parang sa mga, when you see a car na merong stabilizer sa likod, parang ganyan din yun. Because, the sun is giving off yung solar wind. No, not the kind of wind na nadadanasan natin dito. Kung sinabi kong solar wind, I'm talking about ionized particles na nagta-travel through inter-solar system space, no? And this flap actually stabilizes yung si James Webb. Okay. Okay. So that's day 3. Then pagdating ng by day 6 yung sun shield nag-deploy na or nag-unfold na siya. So yung sun shield starts to stretch left and then right. Ganun. Then on day 7, tinension yung sun shield. These sun shields pala is actually made of some special form of silicone and coated with aluminum. So yung heat that we're talking about, yung heat that's coming from the sun will hit the bottom side, the heat that's coming from the sun will hit the bottom side of James Webb, pero it would never, yung heat na yon will never reach the primary mirror ni James Webb. Kasi all that heat, because of the sun shield, all that heat will dissipate. Yun yung purpose ng sun shield na yan. And there's a good reason why they need that sun shield on the James Webb Space Telescope. We'll discuss that a little later. So nga, na-tension niya na siya on day 7. Tapos there are actually 5 layers. 5 layers yan actually. ito pala yung the same sun shield na pinag-usapan natin earlier na napunit. Yan yun. Kasi yung nipis niyan is actually about as thick as a human hair, yung bawat isang layer niyan. So parang kasing nipis lang ng buhok ng kung gaano kalakas ano yung buhok. So ganyan ka-delicate talaga ng yung sun shield niya. Then on day 7, dineploy na yung secondary mirror. So from this configuration na nakatiklop yung secondary mirror, ni-unfold siya like that. That's on day 7, on day 10. And then finally on day 12, nag-extend yung left and right primary mirrors niya. That completes the 18 paneled na primary mirror ni James Webb's telescope. Yeah. So we have a fully deployed telescope. Now I want you to understand something. All this process combines roughly 340 deployment points that has to work perfectly. 340 deployment points na kailangan has to work perfectly. Otherwise, if any of those points somehow failed or doesn't work well, the whole mission's off. Ganun ka-delicate talaga. And so you understand na siguro naman you should understand na why it took so long to launch this space telescope, because it has to work one time every time. Okay? Next tayo. Oops. So yan, we now have a fully deployed James Webb. Okay. Next, it has to travel to a certain special spot in the solar system where it's going to stay for a very long time. Ito yung sinasabi ko natin na Lagrange point. The Lagrange point. What is a Lagrange point? A Lagrange point is a place. Excuse me. A Lagrange point is a place in the Earth's orbit, where the gravitational pull of the Earth and the Sun cancels out. Ulitin ko the Lagrange points are places in the Earth and Sun system where both gravities of the Earth and the Sun cancels out. Ibig sabihin, walang minimal to zero gravitational force ang meron yung spot na yon. Kaya when you put an object there, it'll just stay there for a very long time. Hindi siya ma-influence ng Earth or ng Sun para matanggal siya dun sa point na yon. Okay. And yung point na yun is yung point na pinuntahan ni James Webb is L2. Oops. Yan, itong L2. Ito yung pinuntahan ni James Webb Space Telescope, the Lagrange point 2. And this point is 1.5 million kilometers away. So ganun, no? So once again, dahil sa distance na to, James Webb cannot be serviced, not like Hubble. So in this graph, nakikita natin how yung paano siya pumasok doon sa how James Webb entered into the Lagrange point 2 orbit. So once again, nag-launch siya from the Earth, and then from here all the way to here, nag-deploy yung telescope. Nag-open up yung sun shield, dineploy yung secondary mirror, and dineploy yung primary mirror. And then on day 25, right here, on day 25, it executed what is called a maneuver 2, or what is called also known as the insertion burn, the orbital insertion burn, where it will make this turn and go orbit around the L2 point, which is here. So ibig sabihin nito, hindi siya stationary dun sa L2, no? Hindi siya mag-orbit na stationary lang sa isang point. Si James Webb is actually orbiting, nag-orbit siya around dun sa L2. The reason being kasi once again, si James Webb is solar powered. So if James Webb stays in this area, yung shadow ng Earth matatakpan siya, matatakpan, may possibility na ma-cover siya ng shadow ng Earth or ng Moon. So magkakaroon siya ng problem sa power niya. So it has to remain outside this area para makakuha siya ng solar power from the sun. So it has to orbit this area. O orbit siya na. So if you imagine it, kung na-imagine nyo ito yung Earth and then nag-orbit siya na pa ganun, orbit siya na ganun. So ganyan yung ano niya, yung place niya. Actually, it already James Webb is already made that insertion burn and is already orbiting dun sa L2 point niya. So yeah, success din yan. Success pa rin yan. Next. So let's now talk about the science instruments. Okay? Hanggang sa letter C na pala tayo. Let's talk about the science instruments ng ano. So ito, ano lang to, there's a lot of technical stuff, so I'll just go with the mga basic things na para malaman ninyo. So we'll start from the bottom going up. Okay? So dito sa baba ni James Webb is the spacecraft bus. What that is basically what that is. That's the navigation ni James Webb. The navigation system ni James Webb. It make this part of James Webb tells James Webb na kung tama ang orbit niya, kung tama ba yung location niya sa orbit, ganyan. So that's basically what the spacecraft bus is. Yung star tracker naman, these are little cameras din. These are cameras na chine-check yung positions ng stars to make sure na si James Webb is located properly dun sa, not just located properly, but to make sure that the observations na ginagawa niya is correct. Or naka-position siya to make the proper observation. Yan. Yung mga star trackers. And of course, you have the sun shield, the 5-layered sun shield that keeps the primary mirror from away from extreme heat. No. By the way, when we're talking about temperatures, no, yung temperature differences between the hot part pala itong area na to sa ilalim. Ito yung hot part sa and yung cold part yung sa ibabaw. Yung cold part is this yung dito dun sa opposite side, yung temperature dito sa opposite side ng ng primary mirror, na siya, it's about I think 300 negative 300 to negative 350 degrees Fahrenheit. So ganun ka-efficient yung pag-disperse ng heat ng sun shield. And if you're infrared, you need to be really, really cold. You need kita mo yung infrared light. And then, of course, the primary mirror, the secondary mirror, and ito yung usapan natin earlier, the primary mirror. So when it finally collects the light from a star, all that light, all that observations, papasok kaagad sa mga instruments that is located at the back side ng primary mirror. So once again, ang mangyayari dito is that light light from a star will comes from here, hit the primary mirror, bounce off to the secondary mirror, and the secondary mirror then sends that light into the detector, which is inside this little cone sa center niyan. The same way na dinescribe ni Sir Paul kanina, how reflectors work, how Newtonian reflectors work. Actually, each and all modern telescopes today use reflecting telescopes. There are no modern telescopes that are refracting. Kasi mas cheaper to eh. This is much cheaper and much easier to build. And so, that's how this thing works, no? Basically, ganun. That's how James Webb works. Reflecting telescope siya. Or to be technical, dioptric na telescope siya. Ganyan. Or compound telescope, ika nga. So let's talk about the integrated science instruments. And ito yung mga instruments na makikita inside ISIM, yung dinescribe ko sa timeline earlier. First, let's talk about the fine guidance sensor. A fine guidance sensor, no? This ensures that the guide star availability, which means itong guide sensor na to has also a camera that makes sure na kung ano ino-observe ni James Webb is right on target. Okay, it's kaya nga fine guidance eh. It centers whatever object ang kailangang na ma-observe ni James Webb Telescope. Okay. Now, next is the near-infrared camera. The near-infrared camera. This detects the first light of galaxies and observes galaxies assembly sequences. No? Okay? Tapos yung niya, ito medyo technical but just bear with me for a minute. Yung signals na pwede niyang ma-detect yung near-infrared is 0.6 to 5 microns. Let's use my pointer. Yeah. 0.6. Oops, sorry. Yeah. 0.6 to 5 microns ang nakikita niya na signal na nakikita niya. Okay? And then there's the near infrared spectrograph. Ito naman, once again, near infrared din siya. Kaya ganun din, yun din nakikita niya. 0.6 to 5 microns ang nakikita niya na signal or na light, no? Ganyan. This instrument actually measures the redshift, the metallicity of star formation rates and of first galaxies inside the first galaxies, no? What this instrument does is it takes infrared. It takes the light from a very distant star or galaxy, and then idadaan niya sa prism yun, and then splits that light into its various component colors, yung tinatawag na spectrum, and ina-analyze niya yung spectrum na yun to figure out kung ano yung temperature niya, kung anong temperature ng object na ino-observe, anong temperature niya, ano yung mga elemental components niya, Is it spinning? How fast it's spinning? Is it moving towards us or moving far away from us? Yun yung nagagawa ng instrument na to. And finally, ito yung one of the most yung pinaka na instrument niya. It's this instrument actually distinguishes and explores protostars and their environs. Once again, yung sensor na pinag-usapan natin earlier ng mga near infrared, yung near infrared, so yung nakikita niyang light is 0.6 microns to 5 microns. This instrument, si MIRI, could actually yung nakita niya is nakikita niya is 5 to 25 microns ang nakikita niya na signal, or yung nakikita niyang light na nakikita niya. Ganun ka sensitive yung itong instrument na to. So all this four components combined, ito yung the integrated science instrument module na nakakabit kay . Now once again, lahat to is mostly made and mostly tuned to observe infrared, near infrared, and mid-range infrared. Okay, si Hubble was made to see visible light, a little bit of ultraviolet, and a little bit of infrared. Okay, ganun yung tuning ni Hubble. Yun yung difference ng dalawa. Okay, so if you look at the graph here, ito yung difference ng dalawa. Part D na pala tayo. Looking forward to the past. Okay, ito muna yung difference ng dalawa, ng Hubble and the James Webb Space Telescope. The Hubble Space Telescope has a telescope, yung primary mirror niya has a size of 2.4 meters. Okay, while the James Webb Space Telescope has a 6.5 meter primary mirror. Okay, so what does this mean? It means James Webb Space Telescope has better resolution, better focusing power than Hubble. Yun yung ibig sabihin yun. Like everything else, no? Pagdating sa telescope kasi, like pizza, bigger is better. Ganon. Okay. So that's why so yung the way yung ika nga ay mas malaki ang gathering light power ni James Webb kaysa kay Hubble Space Telescope. All right? So, excuse me. Sa baba, let me show you this sa baba. Sa baba, this shows the spectrum of light, okay? Part of it is yung nakikita yung red, orange, yellow, green, blue, and indigo and violet. These are yung visible spectrum ng light, okay? Hubble is tuned to see yung visible light, itong part na to, from here to here, yung visible light, and a little bit of ultraviolet, and a little bit of infrared. Ito lang yung nakikita niya. Ito yung part of the spectrum na nakikita ni Hubble Space Telescope. Meanwhile, si James Webb Space Telescope cannot see visual light. He's not tuned for that. Yung instruments niya is tuned to see near infrared to mid-range infrared. Ito yung mostly nakikita, yung mga nakikita yung madidetect ni James Webb. So what does this mean? what does this mean actually? First part, because of the size difference ni Hubble at saka ni James Webb, here's a simulation, initial simulation ng mga astronomers kung ano ang makikita ni James Webb versus kay Hubble Space Telescope. The image on the excuse me. The image on the left, yan yung simulation of Hubble observing a quasar. Okay? This is at, nakikita nyo sa baba, 0.5 microns. 0.5 microns, no? Ito lang nakikita niya. Yung quasar na in-observe niya, ito lang nakikita niya. Hindi niya masyadong kita yung inside ng quasar. While si Hubble, because of its large primary mirror, bigger primary mirror, at 1.6 microns, nakikita niya actually yung pinaka quasar itself. Hindi lang just a fuzzy image, but nakikita niya yung quasar itself. Another comparison is ito naman is a wider field, no, of the same quasar. Webb could actually not just see the outer parts of the quasar, which is ito yung mga dust particles and nebulosity ng quasar. It can actually see the quasar itself right in the center. Ganyan. So ganito yung resolution power ni James Webb versus kay Hubble. Ganyan siya has that focusing power ni James Webb. So that's comparative sizes, yung size ng So ngayon, how about yung spectrum? Paano naman yung spectrum? Ito yung, if you take a look at this, and if you follow me for a while, this is if you know about infrared, the way you detect infrared, you have to realize that to see infrared, yung infrared kasi is very, very dim na light yan. And it's far away, so far away. Not only that, but the object that you're actually observing is also moving away from you at the same time. So, since napaka-faint niya, napaka-faint niya, you need to have an instrument that has a low temperature para ma-detect mo yung light na yun, yung infrared light na yun. Pero at the same time, ito yung maganda dito. If you can detect far off light in infrared, you're actually looking at an object. You're looking at an object back in time, because the farther an object is, farther the object is, the farther back in time that you're actually seeing that object. Okay, so basically, when you're doing observations on your telescope, you're looking back in time. Okay, so ito yung comparative reach, ng observable reach ng Hubble versus ni James Webb. Si Hubble could actually see all the way hanggang this far from yung modern yun. Hubble is able to observe mga modern galaxy formations. Hanggang dun lang yung limit niya. Ito, yan. Yan. Hubble can only see modern galaxies forming. Kasi hanggang dun lang yung limit niya. Hanggang dun lang yung makikita ni Hubble Space Telescope. Yes, Hubble can see infrared, pero not enough. Just parang pinatikim lang tayo, konti lang nakikita niyang infrared. But compare that to James Webb, he could actually see the first galaxy formations. We're talking about mga 200 million years after the Big Bang. These are early these are early formations, mga first galaxies, first stars, maybe even first planets na form. So these are yung mga observations na gagawin ni Hubble once fully operational na siya. Okay? So this is the part na gets all astronomers excited, mga astrophysicists. This is the part where they get all excited about, to see galaxy formations and first galaxies that ever forms, the first star that ever forms, the first everything actually, the first everything in the universe na nabuo, ma-observe ni James Webb Telescope kahit ganun na siya kalayo. So that's why we're all excited. Basically, what James Webb will do after all its observations, James Webb will actually rewrite our knowledge of the universe. Everything that we know about the universe right now could change because of the observations and discoveries na magagawa ni James Webb Space Telescope. That's why people remember kanina sa timeline that na ni-review ng NASA and ng review board si James Webb Space Telescope twice, and they still figured na it's still worth kahit umabot siya ng ganun kamahal at ang daming delays, ang daming postponement, it's still worth doing kasi it could answer some of our basic questions about the universe, how the universe started, how galaxies form, how planets form, and all that, how probably even how life formed, kung if we're lucky, di ba? Ganon. So kaya that's why this space telescope is inaabangan ng maraming scientists, inaabangan ng maraming astronomers kung ano yung mga discover niya. So that's why as I said earlier, whatever hype that you heard about this telescope, it's real. Okay, it's so real. Okay, moving on. So, ano yung mga things na makikita ni James Webb? Ano yung mga possible explorations and makukuha natin from James Webb? Its primary aim is to shed light on our cosmic origins. Once again, early formation of the universe, early formation of galaxies and planets, ganyan. And number two, ganun din yung ano niya, it will observe the universe's first galaxies, reveals the birth of stars and planets, ganyan. Ito yung mga things na madidiscover ni James Webb once fully operational na siya. And then number three, it can look for exoplanets and study, not just look for exoplanets, which by the way we have like 3,800 exoplanets already discovered. James Webb could study its atmospheres. Pwedeng ma-observe ni James Webb yung atmospheres ng mga planeta na yun. And by observing the atmospheres of those planets, if those atmospheres is anything close to our atmosphere, sa atmosphere ng Earth, then there's potential life dun sa planet na yun. Regardless kung gaano kalayo yung mga planets na yun. We could assume na kung ganyan din yung atmospheres nila, the same as ours dito sa Earth, then we could assume na mayroong life doon on that planet. So we could be discovering alien life on an exoplanet, on an exosolar system. Yeah. And there are other things na pwedeng ma-discover ni James Webb to cover other scientific research such as dark matter, dark energy, and update on the expansion of the universe, and so on and so forth. So there's a lot of things to learn from the James Webb. So it's not just about launching the biggest telescope, the most advanced telescope in the world. Hindi lang yung bragging rights. This is not just about bragging rights. It's about discovery. It's about exploration. It's about knowing how the universe works. So they're not just throwing away money. They're not just yung efforts nila is hopefully by the time na it's fully functional, James Webb will discover more of our universe than we already have. Okay. So I want to show you this picture. I don't know if you've seen this picture before. This is actually the first picture na nakuha ni James Webb Space Telescope. And I know it's kind of, it doesn't make sense. No, it doesn't make sense at all. Pero this is actually the first picture na kinuha ni James Webb Space Telescope. And it's actually, these pictures are actually a star. Isang star lang to actually. This is just one star. This star is actually found on the constellation ni Ursa Major. If you know about, kung alam niyo yung Big Dipper, ito kung nakita niyo yung Big Dipper na ganyan, andito siya sa part ng where yung merong cup na gano'n, may cup part and then may handle. Yung star na yan is actually off the cup part ng Ursa Major, no? This is just one star. Pero bakit ganito ang gulo-gulo? Kasi when the mirror was deployed, when the primary mirror deployed, all those 18 individual mirrors are actually not aligned. So ito yung initial picture niya. Kasi nakita niyo yung hindi siya single image kasi each individual segments is not aligned. So ang gagawin nila, they have to align pa. That's why matagal din bago magkaroon ng official observation si James Webb. Kasi all those individual mirrors has to be aligned. For example, let's say na itong kamay ko isang segment ng mirror. Some of those images are not even andito nakalagay, hindi naka-center. So they have to first center the image sa bawat individual segments. Ganyan. They have to center all that muna. And then they have to focus it. They have to focus the image. And then they have to align all that sa center sa pinaka center ng primary mirror. Ganyan. So once again, let me show you this next image. Ito yung this is the earlier image, pero this time it's labeled by the individual segments ng mirror, no? Nakikita nyo yung label ng bawat segment kung ano yung part which part of the mirror actually is taking the image, no? Or reflecting the image pala ganyan. So what they are going to do is they will have to align all that. Ito yung left part ng ito yung left part ng deployment ni James Webb. Ito yung right part. Yan. So after that, they have to align it. Yeah, ito naka-align na siya. They all align that. Naka-align na yung mga na-center na nila siya, and then they have to align all that para mag-reflect all the light coming from the star will bounce into the secondary mirror and then back into the center ng As you notice, itong part na to, see this part, medyo hindi siya focus. So they had to focus. Kailangan pa nila i-focus tong mirror na to. Ganyan. So yung ginagawa nila. Kaya rin matagal magkaroon ng observation si James. But finally, hello, can you hear me? Yeah.
Yes, sir, we can hear you.
Ayun, sige. So finally, ito yung last slide ko, no? This is my last slide. James Webb actually took a selfie of itself. Dun sa secondary mirror niya kasi, if ito yung primary mirror, yung secondary mirror niya, meron siyang isang camera din doon that can take pictures of the primary mirror. This way, makikita nila kung if there's something wrong, kung merong basag or merong dumi dun sa mga segments ng mirror niya. And kita nyo yung isang segment dito, merong maliwanag. Isang segment na yan maliwanag. The reason for that is it's reflecting starlight actually. Kaya ganyan ang itsura niyan. Excuse me. So once again, finally, we get to ask the question, and you get to ask the question. Since you're with your young minds and your curious hearts and your curious minds, you can ask yourself the question: after all this effort, $10 billion ang ginastos para magpadala itong space telescope. Ask yourself the question. Kayo mismo sumagot. Is it worth it? Is this whole endeavor worth the time and effort? Not to mention the money. If I were to answer that question, I'd say, yes. Most definitely yes. Because we're not, kasi ganito yun eh. The universe is
Sir, naglag ka po.
The universe is a very big. Okay na?
Hello sir?
Naglalag pa rin?
Okay na sir.
Yun, sige. So yung nga, if you ask me, yes, this is worth the wait. Definitely worth the wait. Kasi the more we know about the universe, the more we know about the universe, the more we know who we are and what's our place in that universe. Did you know, bigyan ko kayo ng example. Back then, and this is calling out on sa mga ladies out there who wants to be scientists. Siguro naman kilala niyo si Madame Curie, no? Madame Curie discovered yung radiation, no? And because of her discovery, yung subsequent, great discovery following in her footsteps, and these discoveries later became useful useful in medical science, mostly in medical science, kasi na-discover niya is about radiation. X-rays, ganyan. X-rays and yun because of Madame Curie, nagkaroon ng understanding how X-rays work, how microwaves work and all that, no? And nung time of these discoveries, nobody was thinking na, uy, X-ray, I can use this sa medicine. Uy, microwave, I can use this as a pang-init ng mga pagkain ko. I can also use this in other medical things. They're not thinking that. They're just making discoveries. Wala sa utak nila na magkakaroon sila that this could be useful for anything else. But this is exactly, we are at that point again with the James Webb Space Telescope. But this time, we're looking out. We're looking back in time. And maybe, and most definitely, if we know more about our universe, we know more about ourselves. Because let's face it, whatever those early stars that James Webb all those stars and galaxies na James Webb will observe in the future, those stars was made and died and formed other stars and galaxies to create heavier elements that eventually created us. I mean, inside stars, uh, na, nabuo ang elements that could create life. Oxygen, sulfur, carbon, and all this, all that, iron pa, no? All this is inside you. All this is a part of you. So making these discoveries, we're not only making these discoveries and making these observations, we not only discover what the universe was, or we also discover ourselves. And looking back, we might even discover ourselves with the James Webb Space Telescope. So the same thing as James Webb took its own selfie, we're also probably be taking observations of who we were and what our place in the universe. So with that, I thank you so much for your time, and maraming salamat ulit for this opportunity. Happy National Astronomy Week, everybody, and good afternoon.
Thank you very much, sir. The hype on the James Webb Telescope is real. Now, sir, para sa akin lang, sir, like, I'm a bit speechless right now, to be honest, since it's really interesting. Like, it made me more invested to know more about the James Webb Telescope, and you brought out the hype, sir. You brought in the energy, sir. Which that was very, very interesting, sir.
I was hoping din na rin to impart that enthusiasm to this to our to you guys, kasi syempre you're still young, you're still at that forefront where discovery and in astronomy could happen. Actually, we are in the golden age of discovery, kasi the questions that we were asking decades ago can now be answered by the methods and tools of science today. So yan, isa na yan si James Webb Space Telescope that is answering those questions. So that's the reason then why my enthusiasm is so great for this telescope, and hopefully you picked up on it.
It is a really, really great invention, sir, which it talks about my timeline siya, sir. Like, imagine, like you said, sir, 11 years, that's 32 years, which that's 11,000 days.
32
and just thinking about that, sir, itself, like the development of it,
I know, right?
It's amazing. Literally amazing. Anyways, the future looks very, very bright for humanity as a whole. And I can't wait to learn more, can't wait to hear more about the revolutionizing discoveries that the James Webb Telescope can uncover.
Oh yeah, by the way, I'll just nakalimutan ko i-mention technically the pinaka first observations na magagawa ni James Webb could happen on somewhere mid-June to early July. Yung the most earliest na ma-release nila yung first images ni James Webb Telescope. That yung picture kanina pinakita ko, that was taken by the fine guidance surveyor na camera. It's not hindi infrared yun. It's not infrared. Hindi ko pala na-mention yun. Pero the infrared instruments are actually na turn on na siya. All the instruments in the James Webb Telescope is already turned on. All they need to do now is to just align yung mga individual segments para to make that first observation. And yung first official release is probably around June or July.
Yes, sir. Well, basically, sir, it's around my birthday na, sir. Once the pictures might be released.
So, yun yung gift ni NASA sa'yo.
Unfortunately, we are running out of time. Like, we went past yung ganun natin, sir. But yes, sir. Kaya let's go ahead. Let's proceed with the Q&A portion of our webinar. So, guys,
yes,
if you guys have any questions, you may raise your virtual raise hand button, or you can type it in the chat box and I'll read it out loud to both. If you have any questions to both Sir Paul or to Sir Lou. So, Sir Lou, may question po sa chat box para sa'yo. So, first, sir, is that he's complimenting you. Like, magaling ka daw, sir, na magturo. and he has a question, sir. What are your guides or lessons for youths who really love to be a scientist in the future, specifically about astronomy or physics?
Yeah. Actually, personally, I had an opportunity to become an astronomer myself. However, responsibilities ko for work took precedence to that. Pero for you guys, kung if that's really your passion, if that's really your passion to pursue science, not just science, but also engineering, or if you want to be kung gusto yung maging lawyer or doctor or Air Force or a pilot, if that's really your passion, then you go for it regardless kung ano sinasabi ng people around you or kung ano man sinasabi mo sa sarili mo. Usually yun yung nagiging hindrance. Yes, for my part, I'm still hoping that I could after all this, I could still go and study yung maging actual astronomer myself. But sa inyo, especially to the young, and with fresh minds and fresh hearts and fresh spirits, na you pursue, if you're into science, you pursue it relentlessly. And if you're passionate about it, don't stop regardless of what people tell you or what you tell yourself. Give yourself a chance. Give yourself that much a chance to pursue your dream, kung whatever that is. Maging astronomer man, engineer, katulad Sir Paul. maging just push forward, push through no matter what. Yun yung encouraging, those are the encouraging words na mabibigay ko sa inyo. Kasi unlike, I'm just going to be magiging personal. Kasi just my parents never really took an interest kung ano yung gusto ko. And I'm just being the opposite of that to you. So kung ano man yung passion ninyo, go for it, regardless of what happens, regardless of what you tell yourself or what other people say. So good. Thank you.
Thank you, sir, very much, sir, for that wonderful speech. It's very inspiring. Anyways, next, sir, to both Sir Paul and Sir Christopher, what are your thoughts on SpaceX? Sino po gusto sa inyo mauna? Sa inyo ni Sir Paul or si Sir Lou?
Paul, baka may baka may sagot ka.
Ano po ulit yung question?
What are your thoughts on SpaceX?
SpaceX. Actually, siguro on how parang ang nakikita ko ngayon is like yung parang space race na nangyari 5 decades ago. Parang yun yung nangyayari ngayon, pero hindi na siya between countries or nations. Parang it's between rich people na ganyan. Parang they're trying to first parang ang gusto nila ay first na makapunta sa ibang planet, parang yung nababasa ko na yung nababasa ko na about kung ano yung gagawin nila is parang about space tourism, like that. So yun yung thought ko about SpaceX.
Actually ako agree din ako dun sa sinabi ni Paul. Actually kasi SpaceX is more of a commercial endeavor rather than exploration and discovery. No. What SpaceX did, if I'm not mistaken, si Elon Musk ang nag-ano nun, no? Pioneer nun. What Elon Musk did is took the yung mga na-discover or yung mga na-discover sa mga equipment at saka mga device and mga things na kailangan gawin na na-discover ni NASA at inimplement niya for the paying public. So ganun lang, it's a commercial endeavor. It's not really a discovery. It could be a way for katulad nagkaroon ng one time nagkaroon ng collaboration between SpaceX and the International Space Station where nag-resupply ang SpaceX sa International Space Station. That's all well and good, pero still it's following in the footsteps kung ano yung ni NASA. So their pursuit of going to space is well, say honorable kasi they're creating stuff, they're creating stuff for in innovation and space exploration as well. They make space exploration more accessible to people like us. No, to the general public. Pero for in discovery and exploration, NASA is king, along with ESA and the Canadian Space Agency, the Japanese Space Agency, and all that.
Thank you very much, sir. Another question po is, what are your thoughts when it comes to planetary colonization? Will humanity ever achieve this?
I think that yun din ang gusto yata ni Elon Musk sa SpaceX niya, di ba? It's aiming for Mars actually. Pero realistically, kung gusto talaga natin maging spacefaring na society, let's go for the moon first. Let's go for the closest thing first muna bago Mars. Maybe sa moon less gravity, so we could launch yung mga launch vehicles would be more easily be launched from there to Mars. Pero one step at a time. Pero yes, there is a big chance that within your lifetimes maabutan nyo yung mga first steps on Mars. My parents they were able to watch that live feed from the moon when Neil Armstrong went to the moon. So sa generation ninyo, you'll be the Mars generation. So hindi malayo yun kasi alam ko by 2030 or by 2040 yung target ni NASA to go to Mars. So hopefully that mangyari yun.
Okay, thank you very much, sir. Okay, may question ako sa'yo, Sir Paul. So as a young and aspiring astronomer, basically like our generation, but I want to hear your point of view on this one. Like, how far do you think humanity can go in terms of space exploration within our timeline?
Within our timeline. The way I see it, siguro parang sa generation natin, parang siguro dito natin mapoprove or nandito na yung ano, parang ito na yung point kung saan malalaman natin kung ma-withstand natin yung ma-withstand yung space technologies and discoveries yung mga problems na meron tayo dito sa Earth ngayon. Kasi yun nga, parang by the time na 2030 ata or 2040 nga, parang balak ni NASA na pumunta ng Mars. Pero madami ding parang predictions na nagsasabi na by the time then hindi na sapat yung water na meron yung humanity, yung climate change ay sobra na, parang mas lalala siya. So if siguro yun yung siguro ito yung generation kung saan malalaman natin kung dito na ba titigil yung human civilization, yung society, or ma-overcome natin yung mga problems na meron tayo sa Earth.
Okay, thank you very much, Sir Paul. Kung wala kayong question, this might be the last question that na maa-ask. So, kay Sir Christopher, I have a question po sa'yo. Actually, I have two questions, but I'll just make it one. So, as in, sir, like, really curious kasi ako sa dalawang question na yun eh. So, the James Webb Telescope can view to the past, right, sir? It's the past on certain like planets as like galaxies and all of that.
Yeah.
So, what if we were able to view another intelligent civilization that looked like us?
Ooh.
And is there a possibility for us to interact with them sometime in like the very far future? If you know.
Here's the thing. If we are to detect life, but it's so easy to detect life. Once again, kung yung katulad kanina, yung pag-usapan kanina, if we analyze yung atmospheres of certain planets, we can deduce that there is life on that planet. Okay, but the question is it intelligent life? Kasi wait, medyo may bias yung word intelligent. Kasi intelligent as we define it. Okay, baka these there are if there's a chance na meron tayong may encounter na intelligent life such as us, medyo I'm optimistic about that, pero statistically speaking, parang mahirap hanapin yun eh. Mahirap hanapin yung mga ganun. Mga life, other life forms can be easily detected. Pero to detect intelligent life, then that's yung pinaka-holy grail eh, in astronomy, actually. To find intelligent life. Or in the minimum, intelligent life as we define it. You know? Ano yung effect nun? Well, it's yung effect nun would be profound actually. Kasi parang, it's like parang ganito eh. What if you encounter a bird, a certain kind of bird na kinausap mo, and then that bird answers back? Parang how would you react to that? Parang ganoon na mangyayari eh. Parang ganoon yung magiging yung analogy ko doon eh. Another life form that lived a very different life to you, experienced different environments experience different things from different environments, ganyan. And then mag-interact kayo. Medyo ano yun eh, profound yun. Especially when medyo maano tayo siguro, maaalog din tayo sa tingin ko eh. as a collective society and in humanity, medyo maano tayo doon. That's the parang last nail ng ego natin, thinking that we're the great, yung species natin, our humanity is the greatest in this universe and all that. Eh, paano yung parang ganun? So,
sir, what if they look like us, sir?
What if they look like us? What if they look like us? Well, kasi ganito yun eh. Under these conditions ng ano natin sa planet natin, ganito yung gravity, ganito yung pressure ng atmosphere, ganito, lalabas talaga yung ganito eh. So we can assume that if a planet that has the same conditions, same gravity, same atmosphere, same temperature, same pressure, we can assume na ganito din magiging itsura nila. We can deduce na ganito rin itsura nila. Kasi this is the best design that nature can build. This is the best thing that nature designed para sa atin here on Earth. Pero siguro there's a slight difference lang kung if ever, for example, mag-iba yung pressure ng planeta na yon, mag-iba yung gravitational forces, mag-iba yung magkakaroon ng pagkakaiba. Pero for them to look like us, pwede. Kung napanood yung movie Avatar, no? Humanoid yung itsura nila eh. We assume na, at saka may bias din dun sa question na yun, kasi we assume that na all life could look like us. Pero hindi. There are certain variables na pwede mag-change that could change din yung appearance ng life form na yun. So yes, it could be humanoid in nature, pero siguro may kakaiba sa kanila. Iba color ng eyes, baka ganun. Pero yung nga, if we are to find alien life that look like us, yung last nail in the ego coffin natin yun. So, yun lang masasabi ko tungkol doon.
Sure, Sir June. And once again, thank you to both Sir Silva and Sir Lou for that amazing, very, very amazing and a very astonishing talk, as well as for imparting their knowledge on the James Webb Telescope and the history of mankind. We hope for more activities, and we hope for more activities soon. Now, may I please call on Miss Angeline Kilang to congratulate our speakers by presenting to them their certificate of appreciation.
Hello, am I audible?
Yes, you are.
I'll be waiting for Miss Agbea and share screen lang. On behalf of the Bedan Society of Young Astronomers, we give the Certificate of Appreciation to Mr. Christopher Liu for being one of our speakers for today's webinar, James Webb Space Telescope and its implication to mankind amidst the pandemic. I thank you, Sir Christopher, for joining us as one of our speakers po. And we also, thank you, sir. And we also want to give the Certificate of Appreciation to Sir Paul De Silva from UP Astronomical Society for being one of our speakers here in our webinar as well. Sir, thank you po for being one of our guest speakers po.
Thank you so much for this opportunity din.
And
ayan, siguro before I turn over to the host, gusto ko talaga magpasalamat personally kay Sir Paul De Villa. First time kayo na ma-invite namin sa BSYA activity. Thank you, sir. It was really very informative yung talk ninyo about the telescope. Hope we can invite you soon sa mga future activities po namin. Care of the UP AstroSoc. So marami pong salamat sa UP AstroSoc. And kay Sir Louis, kay Sir Christopher Lu, thank you po for accepting the invitation. Ka-MSA to si Sir Louis.
Yes.
Yeah.
Yes.
So we belong to the Manila Street Astronomers. And talagang very passionate si Sir Louis sa astronomy.
Sa pareho kami ni Sir June. Thank you. Oh, by the way, my little homage to Sir June. I'm not only wearing the James Webb Space Telescope shirt today. I'm also wearing a little homage from one fanboy to another fanboy.
Ayan, so pareho tayo. Ayan po. Ayan po. Thank you, Sir Louis.
Thank you,
and
happy for the opportunity.
Happy Astronomy Week po sa ating lahat. Alright, back to you, Sir Mr. Shiba Cruz and Miss Angeline Kilang. And sa lahat ng mga na-estudyante dito from the grade 11 STEM, maraming salamat for gracing the occasion. Sana marami kayong natutunan sa mga ka-spacers natin out there. And sa lahat ng mga nanonood po nakatutok sa Facebook, yan, marami pong salamat. Marami pong nanood sa Facebook and shout out sa inyong lahat. No? So happy Astronomy Week po sa lahat. Okay, back to you, Mr. Shiba Cruz.
So once again, congratulations to both of our speakers. Before we end our event, may I request everyone to open their cameras for a picture-taking session. So guys, open kayo ng camera. So para may remembrance naman tayong lahat dito. May I ask at least someone from the officers to take the screenshot. Thank you very much.
Hello? Andito ba si, Miguel? Miguel Arrestante, Mr. Arrestante.
Sa mga gusto pang humabol, mag-open na po kayo ng camera so that we may have our picture-taking session with Sir Christopher Lu and Sir Paul De Silva. Sino ba sa officers pwede mag-take ng screenshot?
Ako na lang siya ba?
Okay, Miguel. Thank you.
Okay na wala. And so 3, 2, 1, smile. Next slide. 3, 2, 1, smile. Okay na po.
Thank you very much, Miguel, for that. So we hope that every one of you have learned a lot about the James Webb Telescope. And to be honest, I believe that this telescope is the key to answering most of our questions about space, about our planet, and about ourselves. And with that, may I call on Prince Patrocinio, Lean Martinez for the closing prayer, the Bedan hymn, and the closing remarks, respectively.
Afternoon to everyone, and firstly, I would like to start by thanking you all for attending this webinar, Looking into the Universe, the James Webb Telescope. Next, I would like to thank our speakers, to Mr. Christopher Lu from Manila Street Astronomers, and to Sir Paul De Silva from UP Astronomical Society, for their excellent and thought-provoking talks on the wonders of the universe. We would also like to give appreciation to the President of the BSYA, Ms. Angeline Kilang, for organizing and animating this webinar and keeping things both under control and reasonably on time. Also, to our club moderator, Sir June Cajigal, for guiding us for this webinar today. However, most importantly, I would like to thank you all, the participants, because without your input, ideas, and discussion, this webinar would not have been the success it has. So, thank you all for everyone, and I encourage you to join us in reaching for the stars.
Let us all reflect and embrace the gracefulness of God. In the name of the Father, the Son, and the Holy Spirit. Lord, as we conclude this wonderful event, we give you thanks for giving us this opportunity of letting all of us gather here who attended this webinar for the primary objective of gaining new significant learnings that will strengthen our intellect in dealing things, especially matters that is included in the field of astronomy. We hope that you will bless us with your guiding hands for us to fully nourish as well as to promulgate the things that we have learned today on different purposes that will benefit ourselves as we venture to our own life equipped with the information we gain from this talk. We also thank you for giving our speakers the capability of disseminating credible information and who openly share their intelligence based on their expertise, which reflect their willingness to share the essence of astronomy that they chose to prolong. As we, the future generation, will continue to intensify these kinds of discussions that will unite everybody in a manner that will bond us all through knowledge. Amen. Saint Bede, pray for us. Saint Benedict, pray for us. Our Lady of Montserrat, pray for us. That in all things, God may be glorified. In the name of the Father, the Son, and the Holy Spirit. Amen.